Hello students, welcome back. We will see one important example on similarity of matrices. Is the following matrix diagonalizable? Justify your answer. They have given a matrix. Let us find the trace of this matrix. So trace is equal to sum of diagonal elements, which is 1 plus 2 plus 3. This is equal to 6. Calculate SMD. That is M11 plus M22 plus M33, which is equal to 6 minus 4. This is M11. M22 is 3 minus 0 plus M33 is 2 plus 2. So 6 minus 4 is 2 plus 3 plus 4. So this is equal to 9. Let us find the determinant of this matrix. I'm going to expand this along with the first row. This is 6 minus 4, which is 2, minus, this is the element E12 into a determinant which contains 1, 2, 2, 3, that is 3 minus 2 plus 0. So 2 plus 2 into 1. So this is equal to 4. Now use the rule to find the characteristic equation, which is lambda cube minus trace of lambda, which is 6 lambda square, plus SMD, which is 9 lambda, minus determinant of A equal to 0. So if you find the roots of this equation, we get 4 and 1. Again, there is one root which is repeated. So how to find the repeated root? We are going to use the concept sum of eigenvalues is equal to trace. Suppose lambda 1 is 4, lambda 2 is 1, and we have to find lambda 3. Trace is here 6. So 5 plus lambda 3 is equal to 6. So third eigenvalue is 1. So in this way, we know that lambda is equal to 4, 1 and 1. These are the eigenvalues of it. Now, definitely here lambda is equal to 4, which is a single eigenvalue. So AM is 1, and definitely we can use the Cramer's rule, and GM is also 1. So for the the diagonalization condition, it depends on only this repeated eigenvalue. Okay, because AM of 1 here, algebraic multiplicity of lambda equal to 1 is 2 here, because 1 is repeated 2 times. Let us calculate the GM. Okay, so if GM of lambda equal to 1 is not equal to 2, right, then AM and GM may not be equal, and matrix A is non-diagonalizable. And if GM is 2, then it is diagonalizable. Okay, so my focus will be on this repeated eigenvalues. So to find the eigenvector associated with lambda equal to 1, you can put this value of lambda in the equation A minus lambda into x is equal to 0. Here lambda is 1, means you need to subtract 1 from diagonal elements. So if I subtract 1 from the diagonal elements, then this will be 0. This is minus 2, 0, 1. 2 minus 1 is 1, and 2. This is 1, 2, and 2 into x1, x2, x3. So as you all know that if eigenvalue is repeated, then you need to reduce coefficient matrix in by using row echelon form. So here this element has to be non-zero element. Okay, so I'm going to switch here R1 and R3. So if I switch R1 and R3, first row is now 1, 2, 2. Second is 1, 1, 2. And third is 0, minus 2 and 0 into x1, x2, x3 is equal to 0, 0, 0. Okay. Now we will use one more transformation to get 0 over here. So I'm going to use R2 minus R1. So if I use R2 minus R1, this will be first row is 1, 2, 2. This will be 0. 1 minus 2 is negative 1. 2 minus 2 is 0. This is 0, minus 2 and 0 into x1, x2, x3 is equal to 0, 0, 0. Yes. Now, one more step here is required. Now, we have to, reduce this element to 0. This is in R3. So, R3 plus or minus R3 minus 2 times R2. So if you do this operation, we will get here 1, 2, 2, then 0, minus 1, 0, and 0, 0, 0 into x1, x2, x3 is equal to 0. So all of you note here, now this is reduced row echelon form, RREF, reduced row echelon form. And if you reduce the coefficient matrix into reduced row echelon form, then just count number of non-zero rows in reduced row echelon form. So there are two non-zero rows in reduced row echelon form. So you can say that rank of this matrix is 2. So here rank is equal to 2 and number of variables are 3. So number of linearly independent eigenvectors is equal to n minus r, that is 3 minus 2 is equal to 1 here. So am, right, for lambda equal to 1 is 2 because 1 has repeated 2 times, and now we have seen gm for lambda equal to 1. Gm means number of linearly independent eigenvectors, which is 1. So here am and gm both are not equal. So for lambda equal to 1, am is not equal to gm. Therefore, by theorem, we can say that A is non-diagonalizable. Yes. Again, I'm going to revise here. The matrix A is non-diagonalizable. I'm going to highlight the points here. Remember, if all eigenvalues of A are distinct, then definitely matrix A is diagonalizable. If eigenvalues of A are repeated, then A may be diagonalizable and may not be diagonalizable. So here it is the case, the given matrix is non-diagonalizable. Here eigenvalues were repeated. And we have used this third point that AM and GM for repeated value, if it is equal, then it is diagonalizable. Here in this case, they are not equal. So this matrix is non-diagonalizable. I hope this article is clear. This topic is also clear. This is the last video of this topic because the syllabus, it starts from eigenvalues and it ends with the similarity of matrices. If matrix is diagonalizable, then we have to find D and M, which is a diagonal matrix and the model matrix. If matrix is non-diagonalizable, no need to find or no need to simplify further. Okay. So question was, is the following matrix diagonalizable? Its answer is no, as AM and GM is not equal for lambda equal to 1. So thank you very much.